So I'm going to be explaining and providing intuition for the nth term test for divergence. So here are these series and their series breakdowns. Uh, Here we have 1 plus 2 plus 3 and on forever. This is a pretty funny Ramanujam sum, but that's not what we're talking about today. Here's the harmonic series and here's the p series at p equals 2. Some of you might recognize that this converges, this diverges, and this diverges, but we're not going to talk about that right now. What we just want to see is how these series behave as we tend towards infinity. So this one, by the nth term divergence test, will diverge, since as we approach infinity, we don't get 0. We get infinity if we take the limit as n approaches infinity of this sequence. For here and here we'll get 0, so these will be inconclusive, but this will be proven to diverge. The idea behind that is that as we get closer to here, we're just adding bigger and bigger numbers to itself as we get closer to infinity. Obviously, that'll just make it keep increasing, almost exponentially. Another way to describe this would be with a series that does something like this: 1 plus 2 plus 4 plus 4 plus 4, and just keep staying at 4. So what we get is we get 3, and then we get 7, then we get 11, then we get like 15. But if we kept going, we're obviously going to reach infinity because these numbers are getting bigger and bigger, right? With here, we're eventually going to get to 0 if we keep going on to infinity, since these are always decreasing. Same over here. So the idea is that these might not get to infinity, but this obviously will, since you're just adding 4 to itself over and over again. If you put 4 times like 1 billion in your calculator, you're going to get like integer overflow. But if you put like 1 over like a billion, you'll get around 0. And from that perspective, it's clear that this will diverge. It's unclear what exactly will happen to these. We might want to say that they'll obviously converge, but in the integral test video, we'll prove why this one doesn't converge and why this one does. But the big idea here is, from an intuitive perspective, we don't know exactly how fast we're getting to 0. Obviously, that's not a rigorous term, but it's a useful way to describe why this doesn't converge, but this does. Since this is obviously decaying faster, since it's to the power of -2 instead of the power of -1. And because of that, it does reach a finite value. This does not reach a finite value because, in some sense, the speed, but I'll prove it more rigorously in the integral test video.